Hello everyone and welcome to the lecture Internet of Things. I'm Neda and today I'm going to talk about connectivity with Wi-Fi. First of all, we do a review of IoT diagram and paths that we've seen in the earlier lectures. After that, we have a review of IoT system and elements, and after this review, we will go through the how to send dummy data to an Adafruit MQTT broker. That is the published side. And after that, we will see how to send a command to a microcontroller, I mean Pico, and control it. That is related to the subscribe side. And after that, we will define the assignment. So let's start. If you remember, we had this IoT roadmap, and we say that we should have a VS Code. We should choose a IDE that we choose VS Code, and a programming language that we choose MicroPython, and we talk about it. And the board that we have is Raspberry Pi Pico W, and the sensor that we chose it was DHT11, and the connectivity that we chose is Wi-Fi. And for the visualization part, for working the protocol, application protocol, we choose MQTT. And for monitoring and visualization here, we choose Adafruit. So this is how we chose about the every part of our roadmap. So a possible path to follow using Wi-Fi connectivity will look like this. That we choose VS Code and MicroPython, and with the board the Pico W and the sensor DHT11, and the connectivity with Wi-Fi, and protocol the protocol that we are using is MQTT, and we are using Adafruit IO. If you remember, in lecture 1, I talked about IoT, and its reference model is entities like sensors, actuator, and client, backend, and gateways, and we saw some examples of each. And in lecture 2, we specifically went through the sensing devices, I mean MCUs like Pico and electronic devices, and got familiar with the temperature sensor, and saw how we could read temperature and humidity values from the sensor. And in lecture 3, we talked about communication and the communication technologies and their features, such as the range, coverage, and speed. Today, we will learn about computation as another element of IoT. So as you can see here, IoT computation involves several concepts that are essential for the functioning and operation of IoT systems. First of all, IoT communication involves analyzing the collected data to derive meaningful insights. It means that we gather the data from these devices that connected to the connected to each other. I mean, this many MCUs like Pico that we have, they get data, they are sensing, and they are producing lots of data. So we can collect this data and do analysis on that data. And advanced analytics techniques such as machine learning and artificial intelligence are employed to discover pattern, trends, and for example anomalies in the data. And these insights can be used to optimize operation and make informed decisions or trigger automated actions. Another concept is actuation that involves sending commands or instruction from another device or system to the microcontroller. In IoT computation, the microcontroller can control physical devices or perform actions based on these commands. For example, if a microcontroller receives a command to turn on a light, it will activate the necessary circuitry to illuminate the light bulb. And actuation allows for remote control and automation of various functions and devices connected to the microcontroller within an IoT system. So today we will see how we can send the command to turn on or turn off the light. So we had this overview of IoT system that we say that, okay, our device, that in this case is Pico, send the data, and we have a Wi-Fi gateway that connects our Pico to the backend, and the data will end up here in Adafruit, and then we can that is called remote sensing, and also we can have remote control that from Adafruit we will send control our Pico to turn on and off the for example the onboard LED on the Pico to turn it on and off. And today we will see both these paths. That is one publish and is another one is subscribe. So let's see how to send dummy data to an Adafruit MQTT broker, and let's see how the publish is happening. This example shows how Raspberry Pi Pico connects to an MQTT broker and publishes random temperature readings at regular intervals every 5 seconds. So steps of doing to accomplish this is that we need to import the necessary libraries, and client and MQTT broker define the client and MQTT broker credentials, and then define a publish topic and its sending interval, and then connection fails to MQTT broker handling function. We should write the function for this connection failure, and then we need to have a function for dummy temperature data reading, and then we will define the main function. So let's start step by step. First of all, import the necessary libraries. So as you can see, we need to import these modules. That is time for time-related function, as we learned before, and macro bin ASCII, and you can see here U as a macro, bin as a binary, and ASCII. That is for binary to ASCII conversion. And then we have micro MQTT simple library that from it we need to use MQTT client, and this is used for MQTT communication, this library. And then we need a machine for communicating with our machine, and in this case our machine is Pico. And then we need to use random for generating random temperature numbers. So dummy values, I mean. I use this random function. So the next step is that client and MQTT broker credentials. So here we have a client ID, and this client ID is set to the hexadecimal representation of the unique ID of the machine that running the code, and the machine here is our Pico. So it will return the Pico W unique ID. And then after that, we need to define that MQTT broker, set it to the address of the MQTT broker. Here is the we created MQTT broker in Adafruit. In the previous lecture we learned how to create. So this is the address. This is the DNS address of that MQTT broker, or it can be IP address, as you can see here. Example of IP address that I commented it can be like this IP address. Either you can use the name or you can use the IP address here. After that, you need to define the port, and since we are not using the security features, the port is 1883. And after that, you need to define your Adafruit username. In my case, is the username is Neda Maliki. You should put your username that you created in MQTT. In the Adafruit IO. And then you need to set your password. This is my password. This is the keys that we get when we create our account on Adafruit. So this is all about the credential that you need from your client, that is your Pico, and the other side, that is MQTT broker in the Adafruit. After that, we need to define a publish topic and its sending interval. So publish topic, you know, that is the MQTT topic to which the temperature readings will be published. And here I set it to this is my user, and /f that shows it is feeds or topic, and /pico w, and encoded as a bytes. And then after that, we need to publish MQTT messages after every set time out. And here, last publish variable will hold the last time a message was sent. And the publish interval is 5 seconds. That means a new message will be sent every 5 seconds. The fourth step is connection fails to MQTT broker handling. We should define this function. And this function is called reset, and it's a function that defined to handle the case when the Pico fails to connect to MQTT broker, and it prints the message like resetting, and after that it sleep for 5 seconds, and then performs a system reset using machine.reset. Your Pico will be reset by this command. So if Pico failed to connect to MQTT broker, this function is calling, and then it will print the resetting message. So the next step is let's generate dummy random temperature values. And using this get temperature reading function, we define to generate a random temperature reading between 20 and 50, and it uses random.rand int function from the random module. If you remember when we imported the random module. And then here in your assignment, you need to read the real value from your sensor data. So the changes that you need to do in your assignment is that you should change this part. This is now the example that you are seeing is just random values, but in your assignment you need to read the real value from your sensor. And after that, this is the main function. So main is the function handles the MQTT connection and publishing of temperature reading. And it starts by printing a message indicating the beginning of the connection attempt with the MQTT broker and specified by MQTT broker. here. And then we create an instance of MQTT client with these arguments, client ID, MQTT broker, port, Adafruit username, and Adafruit password, and keep alive. If you remember, we defined all of these arguments in the previous steps. That is here. All of these are sending as an argument to this MQTT client object here. And then the MQTT client.connect method is called to establish the connection with the MQTT broker. And here, if the connection is successful, a message is printed indicating that the connection has been established, connected to MQTT broker. So after that, the code enters in a while loop that runs for ever. Runs indefinitely because while is true, and then we set here the global last published statement that this global variable declares that the last published variable is global and allows the function to modify the variable defined outside the function's scope, as we learn what is the global variable. And then after that, inside the while loop, we have an if statement that checks whether the time difference between the current time and the last published time is greater than or equal to the published interval, in case it is 5 seconds. And if it's true, if this condition is true, it means that the specified interval has passed since the last published. So we generate a random temperature reading using the getTemperatureReading function. And then the temperature reading is then published to the MQTT broker using MQTT client publish method with the publish topic and the temperature reading encoded as byte, as you can see here. And the last publish variable is updated with the current time using time.time method to mark the time of the last publish. And then a message is printed to indicate that the data has been sent a stop. And then finally the code sleeps for 1 second using time.sleep 1 before going through the loop again. So this structure ensures that temperature readings are published at the specified interval as long as the MQTT connection is active. And this is the main and the line if underline, underline, name, underline, underline, and is strictly equals main. It checks if the current module is being run as the main program and as opposed to being imported as a module into another program. And this condition allows the code within the block be executed only when the module is run directly. And we have a while loop that is used to keep the program running indefinitely. And then within this loop, the try block, we learned about try and except. The try block is used to execute the main function, as we call the main function here. And when we call it, it will go to execute this. This is the main function. We say def, it means function. And then that function is called here. So our program starts from here and it goes to the main. And then all we learn about what is doing in the main. And then after that, if an OS error exception is raised within the try block, it means there is an error related to the operating system or the underlying hardware. And in case of OS error exception, the except block is executed, and it prints an error message that includes the specific exception, and we call it as a string STRE, indicating the type of error that occurred. And after printing the error message, the reset function is called, and this function is defined earlier, as I showed you, and is responsible for handling the case when the Pico fails to connect to the MQTT broker, and it prints a message and sleep for 5 seconds. And then perform a system reset using machine.reset, as we learn in the reset method. And then once the reset function returns, the program goes back to the beginning of the while loop, and the main function is called again. So this structure ensures that the main function is continuously executed, and the OS error exception are catch and handled by printing an error message and performing a system reset. So everything, if everything works fine, you should be able to see the dummy temperature data in the Adafruit IO feeds. So let's see the subscribe part, see how to send a command to a microcontroller and control it. This example shows how Raspberry Pi Pico W subscribes to a topic and is controlled. Controlling means the onboard LED is turned off and on by a toggle button that we define in the Adafruit IO dashboard. So the step that we need is that that should be added to the published code is we define a subscribe topic and set up built-in Pico LED pin, and then define the subscribe message function for controlling Pico W LED, and set the callback function and subscribe to the topic, and define the non-blocking wait for message receiving. So as you can see here, we define a subscribe topic, and I define it as my username, and the feeds, that is F, or it shows topic, and the topic that I define is LED. And after that, I set up the built-in Pico LED as output. As you can see, machine.pin should be .out. And then the received messages for subscriptions will be delivered to this callback function. This is the callback function. Def sub cb topic and message. The topic and message that we get first will be printed, and if the message that we get it is on, that we define it in Adafruit later, we will see. If it is on, it says the LED value 1, and in this case the LED on the Pico will be turned on. And if it is off, else mean if the message we get it is off, the LED value will be set to 0. That it means that the LED will be off. So this is important. The things that we are writing here, it is on in the cap, and we will use it later in Adafruit IO. And also the topic that we define here is LED with the small letters. So we should be careful about this messages that we are defining here. So after that, we set the callback function, and MQTT client will set it with this callback function that we define here, subs underline CB. And then we subscribe to the topic, that the topic that we define here, subscribe topic. And then define the non-blocking wait for message MQTT client.check message. Non-blocking means that your Pico is not waiting for the message that is coming, that continue the execution, the code. Every time the message comes to Pico, it will get it and do the function that is required to be executed, and that's why it's called non-blocking wait. It doesn't wait. Pico doesn't wait for that messages. Whenever the message comes, it will go and do the related steps that is required and related to that message. So if you need whole the code, you can access via these links, and whole of the code, publish and subscribe, exists in this link. So let's see how to create a toggle button in Adafruit IO dashboard. And O should be capped here. Sorry for the typo. You go to Adafruit IO account, and in IO to the dashboard, you need to create a new dashboard. And after that you created the dashboard, you need to create a new block from if you click here, you will see this page, and one of them is create a new block. When you click it, you will see this page that you should choose this toggle button from here. After you choose it, it says that you should connect your your toggle button to a feed. As I created before subscribe topic that is led, and then before we created also Pico for the previous lecture that we wanted to try to create our MQTT broker and tested it with MQTT Explorer. So you can see all the feeds that I have or topics that I have are showing here. So it says that connect your toggle button to one of the feeds. So I choose the LED because in the code we said that it should subscribe to the LED topic, and then we choose it. And the last value, because I worked with it before, the last value that is set for it is off. If you remember, I told you that in the code it is on and off, and this is the value that we set for it. And when we set it, in block setting, you are setting it bottom on text, it should be on, and bottom of text, it should be off. And this on exactly is the on that you see in this code, on. If it is not on, and the else will be executed, and this is off. So after setting the block, then and executing your code, if everything works fine, your Pico should be on and off while you do toggle the bottom on and off, the bottom that you created in Adafruit IO dashboard. So you should be able to see this output. For the assignment, the first part we have done, we create an MQTT broker or server on Adafruit IO, and we created a topic and message on Adafruit and set the permission for that, and we tested it with MQTT Explorer, and we covered in the previous lecture. So for this lecture, the assignment part 2 is that you connect your MQTT client, I mean your Pico, to the MQTT broker via Wi-Fi, and then send the temperature and humidity data of DHT11 to the MQTT broker. And also, that I forget to mention here, I will update it. You need to control your MQTT, your PicoW via the toggle button that you created in Adafruit IO dashboard to turn it on and off. That is whole the assignment that you need to do, and you can find the whole description of the assignment in the CoursePress link. What we learn is that how to connect the Raspberry Pi Pico to the Adafruit MQTT broker, and we learn how to publish on a topic and how to subscribe to a topic, and we learn how to do remote sensing and show the mock temperature data on the Adafruit IO, and we learn how to do remote controlling and control the built-in LED of the Raspberry Pi Pico microcontroller. So the next lecture will be about LAN connectivity with LoRaWAN. So thanks for your time, and if you have any feedback or question, please write me on a Slack, and you are also very welcome to IoT Lab in Kalmar and in my office. Goodbye.